Hello children, welcome to aimsindia's online classes. In today's video from physics subject motion topic we are going to continue. Our today's concept is regarding graphs. In the graphs, regarding motion graphs. Regarding motion graphs we are going to discuss today. In that first type regarding displacement time graphs. Displacement time graphs. So actually, what is the use of these graphs means? They are very useful in studying linear motion of a body. Linear motion of a body. So in these graphs, the displacement is plotted on the y-axis, which means vertical axis, and the time is plotted on x-axis, horizontal axis. Horizontal axis. So if displacement and time is given, we can draw these kind of graphs, and with the help of these graphs, we can find the velocity of a body. With the help of displacement time graph, we can find the velocity of a body. So these graphs are very helpful in finding the velocity of a body. So how to find velocity of the body means it can be calculated with the help of slope of graph. Slope means measurement of y-axis by measurement of x-axis. This ratio is called slope of the graph. But on the y-axis, we have plotted displacement. So measurement of y-axis is nothing but measurement of displacement. On the x-axis, we have plotted time. Measurement of x-axis is nothing but measurement of time. So velocity of the body can be calculated with the help of slope of graph, which in turn equal to ratio of measurement of y-axis by x-axis, which in turn ratio of displacement by time. So we have various kinds of displacement time graphs. Let's study about them one by one. So when the displacement time graph is parallel to time axis, whatever straight line we have drawn here, so this is displacement time graph, or this is the equation representing the linear motion of the body. If the graph, if the displacement time graph is parallel, if it is parallel to the time axis, which is plotted on x-axis, so then the graph will be like this. Then the graph will be like this. Means 0 to 1 seconds. In 1 second time interval, the displacement is 8 meters. 1 to 2 seconds. There also displacement is 8 meters from beginning. From the origin, the displacement is 8 seconds. In the case of a 1 second interval, after 2 seconds also the displacement is same. After 3 seconds also displacement, which is plotted on y-axis, y value at this point is 8, y value after 4 seconds is 8, after 5 seconds is 8, after 6 seconds is 8. Means the x value is changing, the time value is changing, the time is passing on, but whereas the displacement is constant. The displacement is constant. Though the time passes, but the displacement is constant, there is no change in the displacement, then we can call that type of motion as stationary motion, and that body as stationary body. Stationary body. Here the body is considered to be stationary body. So when the displacement time graph is parallel to time axis, then we can guess that the body is stationary without any movement. This is one kind of graph. So the displacement of body is 8 meter when the time is 0. The displacement remains the same, 8 meters after 1 second, 2 seconds, 3 seconds, 4 seconds. Means the body is not changing its position with respect to time. So the body is stationary. So we can conclude that when the displacement time graph is parallel to time axis, the body is said to be stationary. This is one kind of graph. So next, second type. When the displacement time graph is a straight line, but not parallel to time axis. It's a straight line, but not parallel to time axis. If it is like this, this line represents displacement time graph or the motion of the body, which is not parallel to time axis. At 0 seconds, the displacement is 0, this point. At 1 second, after 1 second, displacement is 5, 1, 5, 1, 5, this point. At 2 seconds, displacement is 10 meter. At 2 seconds, x-axis to 10 meters, y-axis 10 meter. If you join these two, this line will come. At 3 seconds, 15 meter per second, 15 meters. At 4 seconds, 15 meter. If the motion of the body is like this graph, and these are all the different coordinates describing the motion of the body. So then what we can conclude is one minute. So when the time gap is 1 second, displacement 5 meters increased. Again in 1 second, 5 to 10, 5 meters increased. Again in 1 second, 2 to 3, 10 to 15, 5 meters increased. For 1 second, 5 meters. 1 second, 5 meters. Means in equal intervals of time, equal amount of displacement is changing. Means the displacement is changing, but uniformly. Displacement is changing uniformly. In equal intervals of time, equal amount of displacement is changed. So that's why we can tell that the body is traveling with a uniform velocity. The body is traveling with a uniform velocity. If a body covers equal displacements in equal intervals of time, then it is said to be moving with uniform velocity. Uniform velocity. Uniform velocity. So if you observe here, this, if you join these points, so here from C to, let this point be B, from C to B, time interval is 2 to 3, 3 to 4, 2 seconds. Delta T means change in time or time interval. Time interval is 2 seconds. What is the displacement change? At B point, displacement is 10. At A point, displacement is 20 meter. Change in displacement is 10 to 20. 10 meter per 10 meters. Change in displacement is 10 meters. Change means delta. Displacement, let it be, if it is on y-axis, delta y equal to 10 meters. So if we take the ratio delta y by delta t, means measurement of displacement by measurement of time, it will give the value of 10 by 2, which is equal to 5. But here meters, seconds, 5 meter per second, which is the velocity of the body. But the velocity is uniform, so this can be considered as uniform velocity of the body. This ratio is nothing but slope of the graph. So in this case, the slope of the graph gives uniform velocity of the body. Uniform velocity of the body. So here, as the graph is straight line, we can tell that displacement is directly proportional to time. As time increases, displacement also increases. But in equal intervals of time, equal amount of displacement is happening. So we can guess that the body is traveling with a uniform velocity. So same whatever we have told now, this is given in the form of text, in the form, no need of this, already we have explained the concept. So thus uniform velocity of the body is delta y bar, because the displacement is mentioned in y direction, delta y bar by delta t. Here displacement is a vector, so that's why we are denoting it as delta y bar. By time is a scalar, simply we can represent it as delta t. Delta y bar delta t equal to AB by AC equal to 10 by 2 equal to 5 meter per second. This is the uniform velocity. So where delta x and, sorry, not delta x, delta y and delta t are small changes in the displacement and time respectively. If the changes are very small, then we can represent with them with the symbol dx bar by dt. Dx bar by dt. Very small change of displacement in very little amount of time interval. This ratio is called instantaneous velocity. Instantaneous velocity. Instantaneous velocity. Because if the time interval is very small, we can, whatever velocity is there, we can tell that it is the velocity at that instant. Because time interval is very small, so that's why we can tell it as velocity at that instant, which is known as instantaneous velocity. Next. Next, third condition. So when the displacement time graph is not a straight line. Not a straight line means if it is like a curve. If it is like a curve. Not a straight line, if it is like a curve. If it is like a curve, so then at 0 seconds, displacement is closer to 2. At 1 seconds, displacement is more than 2. At 2 seconds, displacement is more than 4. After 3 seconds, displacement is more than 10. After 4 seconds, displacement is somewhere more than 16. But here, in equal intervals of change of time, equal amount of displacement is not changing. The amount of displacement, the change of displacement is varying irrespective of time interval. So means in equal intervals of time, it is traveling different displacements. So we can guess it as, guess that velocity as non-uniform velocity or variable velocity. Non-uniform velocity or variable velocity. So displacement is not uniform with respect to time. So body is covering unequal distances in equal intervals of time in specified direction. Though the direction is definite, but the magnitude of change of displacement is not same. So body is moving with variable velocity. The slope of graph at any point gives instantaneous velocity at that point. When the velocity is non-uniform, if it is changing with respect unevenly, then if we take any point, suppose we have taken a point here, the slope at a point is the instantaneous velocity of the body at that point, at that particular instant. Velocity of the body at that particular instant. How to draw slope means we have to draw a line by touching the point, not cutting the point, like touching the point, which is called tangent. The tangent line gives the slope of the body. This is the tangent. It is meeting, suppose this is one point, B point. It is going like this. Let's take B point here, whose value is known, 3 seconds. And here, let's take one point here. another point here whose y value is 2, displacement is 2, time is 3 seconds. If we frame a triangle here with the help of tangent and with the help of these two points B and D, if we extend the points lines, they join at C, we will get a triangle ABCD. We will get a triangle ABCD. The slope of the line will give the value of this instantaneous velocity at point A, measurement of y-axis by measurement of x-axis, 3 by 2, BC by CD. So BC bar by DC, this ratio will give instantaneous velocity at that point. For example, here, suppose if we take BC, BC is nothing but y value. Here, y value changes from 2 to 8, means it is 6 meter. And if we take this value, at D we have 1 second, at C we have 3 seconds. DC measurement will be 2 seconds. 6 meter by 2 seconds. So 6 meter by 2 seconds, 3 meter per second is the correct answer. So this is about displacement time graph and 3 methods children, and 3 different kinds of graphs. So first graph is parallel to time axis. It's a stationary body. Second one is straight line. It tells that it is a body moving with uniform velocity. Third one is not a straight line, it's a curve. It tells that the body is moving with non-uniform velocity or variable velocity. Next one, conclusions that can be drawn from displacement time graphs. So if the graph is parallel to time axis, then the body is stationary. If the graph is straight line but not parallel to time axis, then the body is moving with uniform velocity. That uniform velocity can be calculated with slope of the graph. If the graph is curved, it means that the body is moving with variable velocity. Velocity is changing. So if velocity is changing means there will be acceleration. We can call the body as accelerated body. Accelerated body. The graph line can never be parallel to displacement axis. Can never be. Means if it is like this, it goes on like that only without being parallel to time axis, means can never be parallel to displacement axis. If it is time, if it is displacement, if the graph is never parallel to displacement, means what does it mean? The displacement increases indefinitely. The displacement increases indefinitely without any increase in time. 1 minute, children. So here, two different. This point is not related to 3 different graphs, children. What they are telling is, if they have given can never be parallel. If we assume, if this is time, if this is displacement, if the graph is parallel to displacement, what does it mean? Suppose at 1 second, displacement is 2 meters, 4 meter, 6 meter, 8 meter, 10 meter, means without any change of time, only the displacement will increase continuously. This can never happen. This can never happen. Without increase of time, the displacement at same time, it can never increases indefinitely. So, the displacement time graph parallel to displacement can never be possible. Parallel to time axis can be possible, but displacement time graph parallel to y-axis, parallel to displacement axis can never be possible, which is highly impossible. So these points we have to keep in mind while solving the problems. Okay, children. Regarding velocity time graphs, we can learn later. So thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. You can visit our website, children, aimstoday.in, for information regarding previous online classes, quizzes, worksheets, activities, English classes, coding classes. Thank you, children. Have a good day.